Welcome. Here we're going to talk about the trapezoid and the area and perimeter. So the trapezoid has base 1 and base 2. These two horizontal lines are parallel. The side lengths, S1 and S2, those are not parallel and they may not be the same length. So when we're doing the perimeter, unfortunately, there's really no shortcut. We just have to add all of the four values together. There's nothing else we can do to make that formula any shorter. But the perimeter is we add all four sides together. The area is a little more complex, and I'd like to talk about it a little bit today. So the area is going to be, I wrote P. The area is going to be 1/2 times base 1 plus base 2. It does matter that they are in parentheses here, order of operations, times the height. Now, why is that the case? So let's consider this trapezoid and let's draw out exactly how this is happening. So if I take this trapezoid and I can replicate it. So I'm going to take this base 1, and here base 2 there. I'm going to add that here. And I'm basically replicating the trapezoids so that I have two of them. But I have put the other one upside down so that the sides interlock. And so this distance here is base 2. And this distance here on the bottom is base 1. That's the length, right? So what I've generated now is a parallelogram. So I know how to find the area of a parallelogram. The area of a parallelogram is base times height. But the base in this situation for the parallelogram is the entire distance all the way across. So that's going to be, for this scenario, base 1 plus base 2 times the height. So I'm almost generated my formula here because I have this second component. But the problem is that my parallelogram is just this blue, whereas my trapezoid is just the blue, whereas the parallelogram is the whole thing, and that's twice as big as I need it to be. So in order to get back to just the blue component, in order to get half of it, I multiply this whole thing by 1/2. And my formula ends up being the area for the trapezoid is 1/2 base 1 plus base 2 times the height. Now, just as a note, you may see this also as base 1 plus base 2 divided by 2 times h. Those are all equivalent as far as I'm concerned. They will get you to the same thing. The only thing we really need to be careful about here is the bases, base 1 plus base 2. That needs to be in parentheses so that our order of operations is proper. Let's do an example. So let's consider the following parallelogram. I want to say that so badly. It's a trapezoid. That's how I will draw it. And let's say that the top is 7 inches and the bottom is 19 inches. I have not drawn this to scale. And then the two sides, I have 8 inches, 9 inches, and then we'll have this vertical height as being 6 inches. I would like to find both the perimeter and the area. So the perimeter, again, we add all four sides. So I have 8 inches plus 7 inches plus 9 inches plus 19 inches, and I end up with 43 inches. Be careful to keep your units throughout the problem so that you have proper units in your final answer. And then the area, I'll use my formula. And now I understand where my formula comes from. So if you ever forget it, you can consider, okay, what's the parallelogram? That's base times height. And then the base is the base 1 plus base 2. If you forget, you can recreate it as needed. Anyway, here I have 1/2. The first base is going to be 7 inches, plus the second base, which is 19 inches, and then the height is 6 inches. Using order of operations, I do need to add what's inside my parentheses first. So I'll have 1/2 times 26 inches times 6 inches. And then I can multiply everything through. So 1/2 times 26 times 6 is 78. And then because I have 2 inches here, when I multiply it out, it becomes inches squared. And it should make sense to us that our area always, always, always is in square units. All right, thank you so much for watching.